All right, let's talk about the Oort cloud. You probably have this picture in your head, right? This gigantic frozen junkyard of comets way, way out at the edge of our solar system. Well, what if I told you that entire picture, the one we've believed for decades, is just wrong? So, to really get why this is such a big deal, we gotta go back. We need to look at the old story, the one that's been in textbooks for over 70 years. And yeah, this is pretty much the classic definition. It all comes from Jan Oort's paper back in 1950, and it's been the bedrock of how we think about this thing. It basically paints a picture of this giant cosmic attic, just filled with all the leftover junk from when the planets were being built. And the words to really focus on there have always been static and passive. I mean, we pictured this thing as just an inert shell of cosmic snowballs, just kind of hanging out trillions of miles from home, doing nothing. But it turns out that's not the case at all, not even close. Modern science is telling us a totally different story. All right, so let's get into the new stuff, because that old picture, it's not just missing a few details, it's fundamentally misleading. The Oort cloud is not some passive relic. It's an active, dynamic, and honestly, an incredibly important part of our solar system's entire structure. So here it is, plain and simple. The old myth, a static snowball reservoir. The new reality, a dynamic, protective shell. That's the huge shift in thinking we're talking about. And this is the new definition we're working with. Check out the wording here. Dynamic, actively shields. This isn't just a pile of leftover construction material. No way. It's a functioning piece of our solar system that basically manages the relationship between us and the rest of the Milky Way galaxy. Okay, so you're probably asking, how do we know all this? And that's a fair question. This isn't just some wild guess. This new understanding is built on a really solid foundation of computer simulations and actual observations. You can think of it as standing on four crucial pillars. Right, so these four pillars are its structure and population, how it interacts with the galaxy, its shielding mechanisms, and its long-term stability. Together, these are what completely change the picture from a boring pile of snowballs into a living, breathing system. So let's break them down. First up, let's talk structure and population. And the numbers here are just mind-boggling. We're talking about an estimated 1 trillion objects larger than a kilometer. 1 trillion. That's a 1 with 12 zeros. And this massive swarm of icy bodies forms this huge, spread-out sphere that completely surrounds our solar system. And what's really cool is that it's not just one big blob. It's actually got two distinct parts. You've got the inner Oort cloud, which is kind of flattened because it's still being tugged on by our planets. But then you get to the outer Oort cloud, and it's a nearly perfect sphere. Why? Because it's so far out, our sun's gravity isn't in charge anymore. It's the gravity of the entire Milky Way galaxy that's shaping it. How wild is that? And that brings us right to pillar number 2, how it interacts with the galaxy. See, the cloud isn't just sitting still. It's constantly being stirred up. The Milky Way's gravity, the galactic tide, is always stretching and squeezing it. And on top of that, other stars pass by and give it a gravitational nudge. It's in this constant slow-motion cosmic dance. Which leads us to pillar 3. And this is probably the most surprising part of the whole thing. It has a job, protection. Yeah, that huge spread-out cloud of 1 trillion icy objects, it acts like a shield. It's our solar system's first line of defense against all the stuff flying around in interstellar space. And we're not talking about a small effect here. Look at this. The Oort cloud cuts down the amount of interstellar dust that actually makes it into the inner solar system by a factor of 10 to 100. That's huge. It's basically a cosmic filter for our entire neighborhood. Finally, pillar number 4 is all about stability. You see, the outer part of the cloud is always losing comets. They get knocked out into deep space or sent inwards towards the sun. But it's also constantly getting refilled by objects from the denser inner cloud. So it's not just fading away. It's a sustainable system in a state of balance. And there you have it. Those 4 pillars give us this incredible new picture. Okay, so what? Why does any of this matter? Who cares if the Oort cloud is a dynamic shield instead of just a big pile of snowballs? Well, it turns out the implications are actually huge. For one thing, thinking of it as an active system helps us get way better at predicting the risk of big, long-period comets hitting us. That's pretty important. It also gives us a new way to understand interstellar visitors, like that weird object Oumuamua. And this is the really mind-bending part. It suggests that other stars could have their own protective shells, which might be a key ingredient for making their planets friendly to life. And that just opens up this incredible question, doesn't it? When we spot something like Oumuamua zipping through our solar system, could we be looking at a piece of another star's Oort cloud? A piece of their protective shield that got knocked loose and has been wandering the galaxy for millions of years. When you put it all together, this is so much more than just reclassifying a bunch of rocks and ice way out in space. It's a totally new cosmic perspective. It's a fundamental shift in how we see our little solar system's place in the wider universe. There's a quote from the research that I think just nails it. It says the Oort cloud is a living, evolving, protective shell that links the solar system to the broader galactic ecosystem. It's not a wall keeping us separate. It's the very thing that connects us, a living, evolving shell. I mean, wow. And that just leaves us with this final, amazing thought to chew on. We've basically just found out that our home has this incredible, active shield protecting it. So it really makes you wonder, what else is out there? As we keep looking deeper into the cosmos, what other kinds of cosmic shields are waiting for us to discover?